we're going to look at is the cubic function. So what do you think the parent function equation looks like? Oh, not that. Sorry. All right. The parent function is y equals x cubed instead of x squared because we're looking at a cubic. So think about what happens when you plug numbers into this equation. Our vertex isn't going to look like a vertex anymore. It's not going to be like absolute value or quadratic where the graph turns around, but we're still going to refer to that point as the vertex. That's like the point that started at 0, 0. All of these graphs so far have one of those, because if I plug 0 in for x, I get 0 for y. So it also, just like all the other parent functions we've looked at so far, has this 0, 0 point. When you plug in 1 for x, what do you get for y? 1. Okay, so it has the point 1, 1. And then when you plug in 2 for x, what do you get for y? 8. So 2, 8. So you could keep plugging in and get more points, but kind of like quadratics, if I'm learning the shape of this, I want to know where that vertex point is, and then I want to know like a couple points on each side how they work. So with our quadratic, it was like when you went 1 over, you went 1 up in each direction. When you went 2 over, you went 4 up. And that was kind of what I had memorized in order to be able to know how the parent function works. So with this one, I know that when you go 1 to the right, you go 1 up, and when you go 2 to the right, you go 8 up. What happens when you plug negative 1 into this equation? Yeah, it goes down. So this is what makes it different than a quadratic. You get the point negative 1, negative 1. And then when you plug in negative 2, you get negative 8. Which I don't have room to plot on my graph. Put it down there. Let's put it out there. Okay, so that is what our parent function will look like. Okay, so our vertex, again, it doesn't look like what we think of a vertex, but I'm always talking about that main point that starts in the middle that the whole function is around. So that's going to be our 0, 0 point. What is our domain of this function? All real numbers. You can keep plugging in x values and then keep ending up higher or lower on the graph. So all real numbers. What about the range for this graph? So our results are y values up and down. Is there anything we skip or we don't reach? No. It climbs forever up and forever down. So all real. So this part will be easy to remember for these functions, right? Domain and range is both all real numbers. What is our x-intercept for this graph? 0, 0. And what's our y-intercept? 0, 0. And again, it won't always be that once we shift it and reflect it and things like that, but it will be for the parent function. So this is the stuff that you should have for just the parent function.
If we have a negative one, why doesn't it go into a that level square?
Because it's cubing it as a power instead. So remember, that's like when you plug in negative 1, you're doing negative 1 times negative 1 times another negative 1. So it's turning back negative with the multiplication. Yeah, so all the even powers kind of only end up being positive, but the odd ones include the negative as well. All right. So what we're going to do is we're going to go through and we're going to graph a function step by step. Okay? We're going to do every transformation so that we can fully understand how it works. The biggest thing here that's going to be new for us is that we're focusing more on this stuff that's in here that's multiplying x, okay? And stuff inside the function are what type of changes, horizontal or vertical? Horizontal if they're in there with x, vertical if they're on the outside, okay? So one thing about the horizontal stuff, okay, when we look at the function, and we had to do this before, so this shouldn't be that new. I don't want this to just say negative 1/2 x plus 1. I really need to separate the negative 1/2 from the rest of the quantity. I don't need it to come all the way outside the function and be vertical stuff. It can stay in there, and it can be horizontal changes. But I just need to see what the negative 1/2 on its own compared to the other stuff so that I can see the actual h value. Okay? So right now, if you looked at this, you'd see the plus 1, and you probably think we should shift our graph left 1, but that's not true because this number has been influenced by this negative 1/2 factor. Okay? So remember how we did this. We did this a lot with our step functions, right? And we had to do it with our absolute value functions as well. When we're factoring out the negative 1/2, we're basically looking at each of the terms and thinking what they would be after they were divided by that to see what's left. So if I took negative 1/2 x and divided it by negative 1/2, because that's what I'm factoring out, I would just be left with x. Using that same idea, if I took 1 and divided it by negative 1/2, so if I took 1 and I divided it by negative 1/2, and those of you that struggle with this, you need to write it out so that you get it correct, right? So 1 is being divided by negative 1/2, which means 1 is being multiplied by negative 2 over 1, and that's going to equal negative 2. Negative 2. And if you're not sure if you did it right, check it. If I distributed this back through to each of these terms, would I have what I started with right here? So negative 1/2 times x would be negative 1/2 x. Negative 1/2 times negative 2 would be positive, and 1/2 times 2 would be 1. Okay, so I did a good job. It's exactly what it's supposed to be. Now I can see all of the transformations that I have going on here. So the first thing we're going to do is we're going to start with our parent function. I'm going to start with what I have memorized. Mikey? Negative 1/2 and 3. No, because the negative 1/2 is inside of something that's being cubed, and the 3 is not in there with it, so they actually have very different values. Okay? So what I'm going to do is leave it like this, and what I'm going to do is recognize that the negative, the 1/2, and the -2 are all horizontal changes that I'm going to have to do to the graph, where the 3 and the +2 at the end are vertical changes that I'm going to perform on the graph. So when I look at that, here's what I see. My parent function is y equals x cubed. Then in each step, I'm going to go through and do different transformations in order to obtain the final graph. So again, I want to have memorized that parent function that we talked about. So I'm going to graph that first. So again, where I'm getting these points, I'm getting the exact points that we just made on the parent function. Okay, the vertex was at 0, 0, 1 to the right, 1 up, 2 to the right, 8 up, and then the same thing but downward on the other side. Okay. So there's my parent function. Somebody give me a transformation, and we're going to perform that one transformation. Okay, so Liam says up 2. All right, that's fine. This is a translation. So I'm just going to take the whole entire graph and shift it up 2. So you can literally take every point and count 2 up and replot it on the new graph. Or if you really have the shape memorized well from the vertex, just move the vertex 2 up and then use the pattern you have memorized to put the points around the vertex. Okay? So I'm going to go ahead and do that. I'm going to put the vertex 2 up, and then I'm going to use what I have memorized about 1 away, 1 above, 2 away, 8 above, that kind of thing to get the rest. All right, somebody give me another transformation that we need to perform. What's up? Okay, good. A horizontal stretch of 2, right? So he's looking right here at our 1/2 that's inside of here. Seeing that that 1/2 is inside of the function, okay, it's a horizontal change, so I can write the word horizontal. Remember, all the horizontal stuff is a little crazy. Like this says -2, but what really is our h value? 2, like we move it 2 to the right. Okay, and same thing with this. This says multiply by 1/2, but what do we really multiply by? 2, the reciprocal of it. So before I write the next word, which is either going to be stretch or compression, think about the fact that you're timesing stuff by 2. Does that make things bigger or smaller? If you take numbers and you multiply them by 2, are the numbers going to get bigger or smaller? Bigger. So this is going to be called a horizontal stretch. Now, only one type of transformation moves your vertex, and those are your translations. Everything else should be measured from the vertex. So I'm going to go ahead, since I'm doing a stretch right now, I'm going to put my vertex at the same place that it was. So that's not moving. It's only going to move with the translation. So here's my vertex. Then what's going to change about these points? Their horizontal distance from the vertex or their vertical distance from the vertex? Horizontal, because I'm only working in the horizontal world right now, which means when I think about this point, it's going to be plotted 1 unit above the vertex. That is not going to change because I am doing nothing vertical to it right now. But the question is, how far away from the vertex is it going to end up being? How far away from the vertex horizontally is this point right now? 1 unit. Okay, this distance, 1 unit. I am supposed to be multiplying that distance by 2. That's why I write this little number here, right? Just kind of mentally for me. It doesn't have to be listed with the transformation, but it helps me do it correctly. Okay? So my distance was 1. My stretching factor says to times stuff by 2, and then I know that 1 times 2 turns out to be 2. So I want to replot this point, not change its height vertically, but horizontally, instead of 1 unit away, I want that point to be 2 units away before I go 1 above. Okay? So from my vertex, I'm going to go 2 units away before I plot that point that's 1 above. The point on the left side had the same distance. It was also 1 unit away horizontally. So you can use that same logic and say, okay, that point will now be 2 units away horizontally before I plot that point that's 1 below. Okay, this point that was up here, that was 8 above the vertex, how many units was that horizontally away from the vertex? 2. Okay, here's the vertex, 1, 2 horizontally. Okay, so it had a horizontal distance of 2 units from the vertex. My factor that I'm stretching by is 2, so I'm going to take that distance and times it by 2. 2 times 2 gives me 4. 4 units horizontally is where I want to now plot these points. So instead of going 2 units away and 8 up, I'm going to go 4 units away horizontally before I plot that point that's 8 units above it. Okay? So 1, 2, 3, 4 horizontally before I go up 8. 1, 2, 3. Now, because this point on the other side down here was also 2 away horizontally, all the arithmetic would be the same. So I know I want to plot that point 4 away horizontally before I go 8 down. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Notice I didn't change any of the vertical distances. Okay, the vertex stayed exactly where it was. It only moves with translations. All the other points didn't move any higher or lower. They just got further away from the vertex horizontally because I was doing a horizontal stretch. Okay, and I did a little calculation with the original distance times my little number right here to figure out exactly where to put that. Okay, so then this is now what I have. Okay? Is this all right with everybody? Okay, so with a horizontal stretch, you're just measuring how far points are horizontally, timesing them by the factor, and then using that new distance as their horizontal distance from the vertex. All right, what do you guys want to do next? So we've done the horizontal stretch, so we've kind of taken care of what this does, and we've done the up to, so we've kind of taken care of what this does. So we still have a 3, a negative, and a minus 2 in there with x to take care of in order for us to finish. John? Okay, so vertical stretch is going to be the same kind of procedure, but now we're going to be looking at all the points and their vertical distance. And we're starting where we are because we've already done work. We don't want to undo any of that work that we've done. Okay? So when we go to plot our next step, our vertex is going to stay the same, okay? Because vertex is only going to move with the translation. So my next step, he said we're going to do a vertical stretch. If you weren't sure if it was a stretch or not, you'd write the word vertical because the 3 was on the outside. Think about what that means. With the vertical stuff, you just multiply by exactly your number. You don't have to change it. If you're timesing distances by 3, they're going to be getting bigger, which is why I would determine that this should be a stretch. Okay? So there's going to be a vertical stretch. So again, my vertex stays the same. It only changes with translation. Okay? So I have my vertex. Am I going to change how far any of these points are horizontally from the vertex right now? No, because I'm only focusing on a vertical change right now. Okay, one thing at a time. So when I go back and look at the distances that I have, for example, this point right here, 2 units away horizontally, and then it was 1 unit above vertically. The 2 units away horizontally is not going to change. I am not doing a horizontal change right now. I'm still going to go to my vertex and plot some point that's 2 units away horizontally. The question now is, what will its distance be vertically? So right now the distance is 1, okay? But what's my vertical stretch factor? 3. So I'm going to times that by 3. 1 times 3 is 3. I want this new distance right here to be 3, meaning when I look at my vertex, the point that I plot 2 units to the right, I don't want it to be 1 unit above. I want it to now be 3 units above. That's the new distance measurement that I want. Okay, so on my graph, from my vertex, from my vertex, that point that was 2 away horizontally is still going to be 2 away horizontally, but rather than being 1 unit above, based on my little calculation, it should be 3 units above. The point that's kind of the mirror image of that on the other side, okay, the point that was 2 units to the left and 1 unit below, will now be 2 units to the left and 3 units below, because the arithmetic would be the same. Okay. So I have my vertex, and based on that one calculation, I got these 2 points around it. Let's go back to my graph and look at the other points. Okay, so the other points I'm concerned about are here. These points are 4 units away horizontally, and then they are 8 units away vertically. Okay? Again, I'm not changing anything horizontally right now. So when I go graph my new version of this, I'm still going to graph things 4 units away horizontally. What would change is the number 8. It should get multiplied by a factor of 3 because that's the vertical stretch factor that we're dealing with right now. 8 times 3 would be 24. Okay? That means that on my graph, points that were 4 away and 8 above, we now want them to be 4 away and 24 units above. Now, I don't have 24 units to graph, which is fine. I can leave it like this. But it just means that as I draw it, I'm going to try to draw it at the correct steepness that it would go to about 24 if they continued it. Okay? So something like this. And yes, I can grade this because I can look right here and see these measurements and know if you stretched it by 3 or not, even though I don't have the second set of points of this thing. Okay? All right, so looking back at our equation, we've now done the vertical stretch of 3. We haven't taken care of the negative that's here or the minus 2 that's here. Somebody give me another transformation that needs to be performed. Sean? Okay, good. So this minus 2 inside with the x, the h is actually positive 2, which means we're shifting everything 2 to the right. So we're going to do a translation. Right 2. Okay? So I'm just going to take everything on the graph and move it to the right 2. Okay? So this does affect my vertex. Remember, translations are the only things that affect your vertex. So this was 2 above. I now want it to be also 2 to the right. So it's going to be at the point 2, 2. You can either move the other points 2 to the right as well, Or you can just say, oh, there was a point that was 2 away from it to the right and 3 above it, and you could kind of plot that on here. And then there was another point that was 2 to the left and 3 below, and plot that on here. And drawing your steep curve. Okay. And then we've shifted everything 2 to the right. Okay. All right, so what's the only transformation that we haven't addressed? Yeah, this negative right here. Multiplying by negative is what kind of transformation for us? A reflection, and because it's on the inside, it's horizontal. What does it mean to be a horizontal reflection? So horizontal means things that are on the left, I want them to go to the right, and things that are on the right, I want them to go to the left. So what am I going to flip over? The y-axis. Okay, so you would either label this a horizontal reflection, or you would say something, you would have to include the word reflection still, but you could say over the y-axis. Now, we're not technically going to do it over the y-axis, and the reason is I kind of let you guys do the transformations in whatever order you want. What are the only transformations that move our vertex? Translations, shifting left and right. That means, do I want to move this again if I'm not doing a translation? No, I don't want to flip it over. This guy's in the right spot. Okay, so because we did that stuff first, we're kind of using our vertex as our mirror, and basically things that are on the right side of the vertex need to now come on the left side of the vertex, and things that are on the left side of the vertex need to now come on the right. So again, my vertex is now going to stay in its spot. So what I used to have is I had this point right here. It was 3 above the vertex, and it was 2 to the right. I now want to plot that point so that it's on the other side of the vertex horizontally. So 3 above the vertex, but instead of being 2 to the right, I want that point to be 2 to the left. Okay? And this point over here, that was 3 below the vertex, and it was 2 on the left side, I want to flip it over horizontally, and I want it to be on the right side. Okay, so I am still going to go 3 below the vertex, but rather than being over here to the left, I want that point over here to the right. Okay? And so it's going to make my cubic kind of switch directions and look like it's going the other way. Okay? So this is kind of the most work you would ever have to do, because this had both a horizontal and vertical translation, it had a reflection, it had a vertical stretch or compression, and a horizontal stretch or compression. So that's kind of the most that you guys would ever have to do, is to walk through this amount of steps. Okay? So I wanted to do each one separately so that when you just have one transformation, you've seen an example of how to do that. Okay? If I forget how to do a reflection, I could just come here and look at this and say, okay, if the graph looks like this, this is what a horizontal reflection did to that. And then I could try and do that on my paper. Depending on where you're at as a student, you don't have to do all of that every time. Okay? And so we'll do one other example. There's 2 more on your paper, but we'll just do one. And we'll talk about another way that you could do this. So here's an example of a cubic. Okay? It's going to be a little less complicated because we don't have a horizontal stretch or compression. We only have a vertical one. Okay? So what we do have, we have a vertical reflection. And then we have a 2 out here. What is this going to be? So out here we have a -2. What is the 2 part going to do? First of all, is it vertical or horizontal? Vertical, because it's outside of what's being cubed, right? Okay, so it's vertical. It's multiplying, so I'm going to multiply by stuff, and with vertical, I multiply by the exact number that's there. So if I times things by 2, am I going to make them bigger or smaller? You take numbers and times them by 2, you make them bigger, so we would call this a vertical stretch. By 2, because the negative I'm always counting as its own transformation in the reflection. Okay? All right, what are my h and k values here? Good, -3, -1. So my translations are going to be left 3 and down 1. So one way to do this, if you're good with plotting the whole HK thing, because we've been doing some of this before, right, and starting our graphs there, you can still start your graph there as your vertex point. So one thing I could do is I could actually do this part first if I wanted, okay, and put my vertex at that left 3 down 1, negative 3, negative 1. So negative 3, negative 1. I can put my vertex there. Okay? And then I can remember what I am graphing. Am I graphing a step function, absolute value, quadratic, or cubic here? Cubic, okay, because of the third power. So I have to remember that that means that it looks like this. How do I know that it looks like this? I memorized my parent function, okay? All right, so here I've taken care of both of these, meaning if the 3 and the 1 were the only transformations, I would be done completely with the graph, okay? But I still have to reflect and do a vertical stretch, okay? This reflection is vertical, so where are my points going to go? Kind of like flipping over the x-axis, but because I've already moved my vertex, it's not going to move again, right? So left 3, down 1, it's going to be in this right place the whole time. But the points that were above the vertex, I now want them to be below. And the points that were below, I want them to be above. That's a vertical reflection. So you would see that by this point that was above going below. And the other point that was above going below. And then the points that were below would now look like they were above. Notice for these graphs, a horizontal reflection and a vertical reflection kind of look the same. Okay? It's not going to happen in all of the shapes. They each kind of have something that's like, oh, that one looks the same as that. That's true for one shape, but not the other. Okay, the last thing then, yeah, Mikey, sorry. I haven't done the 2 yet. So those are 2 different transformations. The negative is just the reflection, and now I'm going to do the stretch by a factor of 2. So again, my vertex would stay, and my stretch is vertical. So the vertical distances will change. So this guy right here, he's currently 1 unit below the vertex. I would times that by 2, and I want him to show up in my final graph 2 units below the vertex. So 1 over and 2 below. Okay? And same with the one that was above. This guy right here, how far below the vertex was he? His vertical distance from the vertex down to this guy. Yeah, so he's 8 units below. When I times that by 2, that's going to be 16. So my other points would be plotted 16 units away. Again, that's a little hard with the size of our graphs here to plot a point 16 units away, and that's okay. You don't have to do that. You just have to then fill in your curve. Okay. So you can start by just moving the vertex first if that's helpful to you. You can write out all the transformations like we did before, but now at least you have multiple examples to look at when you work on your homework. And again, you're not going to work on the problems that go with this until Friday after you've taken your quiz. But I just wanted to make sure the day before your quiz was review, specifically for your quiz, and that the substitute didn't have to teach you guys anything.